Good evening, students. I am Dr. Vasumathi, working as Associate Professor in Vignan Smidula Engineering College. Today the concept is random forest. As name implies, it combines and all the weaker algorithms and it's made it as stronger algorithm. That's why it's a forest. Random forest algorithm. Random forest algorithm. So here mainly it concentrates on which are the weaker algorithms, weaker classifier, weaker classification techniques. So these weaker classification techniques, the main problem is here it will concentrate only on some of the aspects in the entire algorithm, and in entire running sets also. Here it can't concentrate on all the data sets. So some of the points will be covered, and which are for that only the prediction is being given by the weaker algorithms. So that is not possible. No? So that's why here these weaker algorithms, we have to make it as stronger. We have to make it as stronger. That is the main purpose of the random forest model is. So this is designed by Raymond in 2001, and this is a kind of ensemble learning technique. Ensemble means combine all the stronger, all the weaker, and all make it as a very good learning algorithm. That is the random forest algorithm. Okay. Yes. Here, what is the main purpose of the trees? Tree is a one hierarchical structure. It starts from the root node and it takes many more branches, and by depending on certain decision making nodes, and it can identify the leaves. So till there is no further deviation and further decision that you can make. So there up to then, here it calculates and it here just it goes on till the leaf nodes. That is a tree structure, usual tree structure. Here in this random forest, the main concept of trees is being applied. In this random forest algorithm, the main decision tree, the root node from the root node, each node is being considered as a decision node. And here in this, the random forest starts with a standard machine learning technique called a decision tree. Decision tree, which in ensemble terms corresponds to a weaker learner. So this is in the decision tree, whatever the limitations have been there, these limitations, all these limitations have been addressed in the random forest technique. So that is the trees and forest. This is the main purpose. Here if you will observe, in a decision tree, an input is entered as the top. So that is nothing but the input instance, and that input instance and being taking many more decisions from each and every node. Each and every internal node, you can consider it as a one decision node. Okay, so this from this each and every decision node, you can go to the leaf nodes finally. These leaf nodes are the nodes which consist of your final predictions. So based on that, this is a normal structure. Based on that, you can make up any decision tree, and but this decision tree is a main concept behind the backbone of this random forest algorithm. So here in this random forest, the main concept is the decision tree, and that too the weaker learner. The weaker learner, and these weaker learners are being then strongest. So here these weaker learners are combined together, and these are trained well to give the very excellent stronger algorithm. So entirely as together combine all this, and that is how we can call this as the ensemble learning technique. So this is the trees and forest. So trees and forest means here we can consider one example, trees and forest. See here, this is one of the variable. Here the dependent variable is play. Consider this flow chart, and this is the nothing but the decision tree, where the decision variable, here you can observe what is the decision variable? To play. So when will you play? If the environment is clear, if the environment is sunny, you can play. If the environment is rainy, we can't play. Now if we understand, if we want to go ahead further, what is the probability of chances to play, whether can play or not. So further we can just make up certain decision tree based lines. See here we can observe this is the root node, and these are the decision making nodes, and this rectangular box, this is the rectangular box. This rectangular box represents that these are the lymph nodes. Here to play or not, according to this the decision tree. This is the decision tree. Why? Because each node is a one type of decision making, and from that you can go either this type or this way. So here two paths have been represented. See, consider here dependent variable here is play. Play is 9 chances, don't play is 5 chances. So for this we have to observe the outlook. Here 3 outlook variables you have considered: sunny, forecast and rainy. Sunny, can you play? Yes, even then sunny, you can't play to some certain extents, because if the humidity value is more, so there is no chance to play freely. So there is a possibility of not to play. Don't play probability is also will be there in the sunny condition. So if it is sunny we can play. You can't think like that. If it is even sunny also, in some situations we can't play. So that is the here this decision node will takes. Okay. So if it is sunny and if the humidity value is less than or equal to 70, then only you can play. See, observe this ma. Here play is 2, don't play is 0. So which is greater? Play is greater. So which is the what is the probability here? To play. So there are more chances to play than don't play. Okay. So this is what the way here you are just giving the majority. You are giving the importance to majority. In the last class we have discussed, if you are giving the majority option, majority in this prediction, what you can call it as bagging and pasting. Okay. So here this is the in this play 2 and don't play is 0. So this is voting classifiers. Voting classifiers, that to hard voting. We can consider this as the hard voting, which gives the priority to the majority of the cases. Soft voting means you can apply some certain soft technique to get the final prediction. Here the final prediction in this path, in this entire path, the final prediction you can predict orally. Just that is nothing but to play. You can play whenever if it is sunny. And suppose if it is outlook, if the outlook is overcast, then what is the probability of the play is 4, don't play is 0. Okay, right? So this is what the way. If it is a rainy, if the rainy condition, play is even 3, don't play is 2. Based on the wind, if it is windy, if it is true, then play is 0, don't play is 2. Okay, so this is giving more priority, more probability to not to play. Don't go for playing if there is a certain situation that is rainy and wind flow is high. If the wind flow is high, then don't play. If the wind flow is little, you can play even in rainy situation also. So yes, here what are the things that you have to observe is, the first one is what is the variable? The decision variable, the dependent variable. Here the dependent variable is play. The dependent variable is play. So this dependent variable you can finally give the solution and you can finally give the prediction of this decision tree, that is whether to play or not. This is nothing but the usual decision tree pattern. So here in this case we are having so many certain designing issues and so many certain limitations in this entire thing. So all this we can rectify in the random forest algorithm. Random forest algorithm, it concentrates on all types of variables. Here how many variables we have considered? Sunny, overcast, rain. So this you can consider it as m number of variables. And how many number of leaf nodes we have designed in this? So that is 4. So is it 4 or further can you design? Further means again more and more just certain other aspects we have to decide. Is there humidity? Is there any? If it is sunny and humidity, and if is there any other option? If is there any other chances for not to play and for play? So that is all you have to calculate. So whether to go for in-depth study or not, that is also we can give in the algorithm. In the algorithm of the random forest. So that is itself represents that how many number of leaf nodes. How many number of leaf nodes. So here what is a leaf node? This is one of the leaf nodes. 1, 2, 3, 4. These are the leaf nodes. So here 4 leaf nodes have been there. So number of leaf nodes is also you can set. Don't go in depth. 4 leaf nodes, that is enough. So you can set in the algorithm. Okay. So this is what the trees and forests. Yes. The main concept in this, the random forest, here the random forest takes this notion to the next level by combining these trees. Just now I have explained here, it combines all these weaker algorithms and certain aspects which were not covered previously. All these will be covered in the random forest algorithm. So in the random forest, the same thing, the same you can observe. This is all nothing but all the data, and this is the random sub data. This is a tree. This is a tree, and all these are the trees. From all these trees, you can decide. You can get ahead the final sub tree. So all these sub trees you can get from all these. This is one certain weaker algorithm, and this is another weaker algorithm. And this may be strong or weak, and from all these algorithms you can get the final. At each node here, at each node we have to choose certain small subset of variables at random and to find a final variable, final prediction. So here this is a tree random subset. All these are the random subsets of the data. In the last class we have just considered, that is voting classifiers. That is one of the designing issues, and another one is in what way, in what pattern you can distribute the training data set. So for that concept here, this is all the data. This is nothing but your overall training data set. This training data set is distributed randomly to your tree. And finally, whatever the predictions have been done here in this tree and all, so the final tree you can consider here. And this is what the main thing here. In what way will you distribute the training data samples? Training data set. Training data set not just given it to overall to all the classifiers. There is you can apply certain technique there. So that technique is bagging and pasting, boosting, stacking, all these techniques. So all these techniques, with the help of any one of these techniques, just we can distribute. This is the random forest algorithm. Here the algorithm is, just now I have explained here, the number of leaf nodes are also you can set. See here, first you have to set the B variable to 1 to B. So how many number of nodes that you wish to get? How many number of classifiers that you wish to get? That is what you have to set. Draw a bootstrap sample Z star of size n. So here bootstrap, what do you mean by the bootstrap? Here what is the bootstrap? Bootstrap technique, bootstrap aggregation, that is bagging. In bagging, what will you do? You will randomly pick certain data sets, and these data sets you will give to the first classifier some of the random samples, and for the second classifier some another random samples to the second classifier, and for the third classifier some another random samples to the third classifier. So like this you can distribute, that is you can call it as the bootstrap. So you are having total n number of data sets. So in this you have to pick any number. That is what this step. Draw a bootstrap sample Z star of size n from the training data set. So here you are not being given the training data set entirely to all these classifiers at a time. Here you are applying some bootstrap aggregation. That is the first step we have to do in the random forest algorithm. And the next one is grow a random forest tree to the bootstrapped data. So whatever the data that you have selected from overall training data set. So for that you have to just draw a decision method. decision tree, that is the random, that you can call it as here, as a name is random forest algorithm. So here you can call it as random forest tree. Okay, so but this is not a decision tree. You have to grow a random forest tree. See, in the random forest tree, how many number of leaf nodes, that is also you have to set in the Python code. You have to set the how many number of leaf nodes. So based on that, for the given bootstrapped data, the random forest tree is being prepared, and by recursively repeating the following steps for each terminal node of the tree until the minimum node is n minimum that is reached. So here you have to select m variables at random from the p variables. So you can have previously so here m variables you have to select out of p variables means, what do you mean by m here is nothing but this is. So if you want to play or not, what are the probable weather conditions means only 3, no? Is there any other? Can you guess, is there any other? So actually it will be 3. Maybe some other fourth variable is also there, but here out of all probabilities select any 3 or any 2, sunny, rainy, these 2 only I will consider, then okay, no problem at all, you can consider. Select only either sunny or rainy. So that number you can call it as the m. Out of p you have to consider the m variable value, that is nothing but the sunny, overcast and rain. So these 3 will become the m. So here out of which you have to select the m variable at random from the p variables and pick the best variable split point among the m. So here in all these decision making nodes, you have to give the better decision making step at each and every internal nodes of the random forest tree. In the random forest tree, you have to pick the best variable. So that is the split point among all this m. Okay. So then split the node into 2 daughter nodes. Daughter nodes output the ensemble of trees. So for this, you can prepare so many different types of random forest trees. There is no only one representation. You can go ahead with the many more internal representations. In the previous example, I have considered it as the humidity less than or equal to 70. So is it exactly 70? Or humidity is shall we consider only humidity? Is there any other example? Yes, go ahead. You can go with the other patterns and other decision making nodes also. So how many in number, that is having a fixed limit, and based on that you can have so many different types of decision making trees. All these you can call it as the random forest trees. In the random forest trees, in the last class just I have explained, here you are having the majority vote. So for each classification here, to make prediction at a new point, we have to do for the following. So what is that? Regression is there, classification is there. If it is regression, select the voting classifier as the soft voting. Soft voting means averages of all. Hard voting means that is the majority. So if it is classification, either this class or that class, then go ahead for the majority vote. Okay, because these two, if it is the classification, the majority voting classifier means what? That is hard voting classifier. This is also you can fix in the Python code. In the Python code, that voting classifier, set it as hard. And if you want to go ahead for the average results, you can set it as soft. Okay. So in this way, you can set these two, either average the results or majority rule you have to follow. So that is you can set in the Python code, and the term is that vote. So what type of vote? Is it majority vote or is it soft vote? You can represent. Okay, so that is if it is regression, average results. If it is classification, majority vote. Okay, right. So this is how you can create. So based on that, just now I have explained, here you can have so many different types of many more decisions you can apply in your tree. so that it generates different types of trees. So in all these trees you can check it the new samples also. For example, let us consider the tree 1, tree 2 and tree 3. In the tree 1, here it observes the person. So the person, is the person old person or young? Is the person is deceased or not? And if the person is deceased and it checks that is he tall or short? And if he tall, then it selects it as, it gives the prediction it as healthy. And otherwise it gives the prediction it as deceased. This tree is helpful whether the given person is healthy or deceased. This is the tree 1 representation. Can you just observe the difference between the tree 1 and tree 2? What is the difference between the tree 1 and tree 2? Coming to the first attribute, so here this is the old young and this is also old young. And here deceased healthy, of course this is healthy deceased. In this healthy, male female. So another type of categorization is male female. And what is the categorization here? Tall, short. Which one is better? That is your algorithm. So that is your algorithm, and based on that you can go ahead and you can select. So, and it gives that whether the person is healthy or not, and the person is deceased. This is another way of representation. This is another decision tree, random forest tree. And the same way you can also have another representation. Here you have observed, you have considered many other different patterns, that is the person is working or is the person is retired. So retired work. If the person is retired, it checks that healthy, tall. If the person is tall, it gives it as healthy. If the person is retired, healthy and short, then this is as deceased. So this flow you have to consider for the prediction deceased, and this flow you have to consider if the person is healthy. So like this, it just makes the decision from one node to the another node. Based on that, it can categorize and it can give. Let us check all these trees. Consider one new sample, and in the new sample you are having all these attributes. The person is old, the person is retired, the person is male, and the person is short. So for this, the tree predictions, the tree 1 gives that deceased, and tree 2 represents that the person is healthy, and tree 3 represents that the person is deceased. So for this, the given new sample, it represents that deceased, healthy and deceased. So here, if you are applying which rule, here you are applying majority rule. Majority rule means what type of voting classifier is that? Hard voting. Hard voting. So here, if you will apply in the Python code, if you will apply the voting as hard voting, then it gives that it as a deceased. So in this way, you can go ahead and you can generate so many different types of the trees, and you can just generate number of different types of the trees, and based on that you can select. So there are many more advantages of the random forest algorithm, and you can apply even medicinal purpose, and you can apply in the whether the person is deceased or not, cancer patient or not. Based on the data sets you can apply, and you can apply in the banking, and you can apply in the educational purpose. Just many more applications have been there, and these are the advantages of the random forest algorithm.